Exception handling in .NET is all based on the concept of using instances of the exception class to contain information about an error that has occurred. Each instance of the exception class will contain information about the current error that just occurred, and at any point you can have a linked list of errors that were raised to trigger this error, so that any error handling can take an error, add on more information, including the old error, and pass it on up to the caller. So you could end up with a linked list of errors, all that were passed through to get to the current error handling location. In addition, you can inherit from the exception class. We'll look at an example of this later on in this discussion. Almost every method in the .NET framework raises an exception to indicate an error condition. Now you'll use the try, catch, finally block to trap these errors, and you can nest these try, catch blocks, and that makes it easier to effectively push and pop error handlers. Have different exception handlers at different places in your code based on the kinds of activities you want to check for. It's the try, catch, and finally blocks that allow you to do your work. A try block allows you to try some code. If it raises an exception, the code will jump to the most local catch block it can find, either in the same procedure or in the calling procedure. The finally block allows us to run code unconditionally, whether or not an exception occurred. Let's start by examining a demonstration that has no exception handling at all. I've loaded the sample project for this chapter, and I'll press F5 to run it, and you'll see this exception handling demonstration is going to allow us to search and use a file whose name we specify in a number of different situations. Here we have no error handling, and I'm looking for a:/autoexec.bat. Well, I have no drive A, and if I did have a drive A, there's no floppy in it, that's for sure. So the device isn't ready. We get an I/O exception. This is called the exception assistant. You'll see that we can turn it off, but before we do, let's try some other kinds of exceptions. Let's run it once again, and this time let's look for C:. That file doesn't exist. And this time, we couldn't find the file. Okay, let's try another one. Let's try Q:, because I don't have a drive Q. And this time, it couldn't find a part of that path. Okay, yes, it couldn't. Drive Q doesn't exist. So you can see there are a number of different kinds of errors that might occur because of that file not being there. Well, that exception assistant is useful, I suppose, but you may find that it gets in your way, and it will for our demonstration today. So I'm going to go to the Tools Options menu and turn it off. We don't need the exception assistant today. Most often you'll want to leave it on for your debugging, and without that there, here's what you see inside Visual Studio. Just the option to break or continue and information about the exception that occurred. Here I can continue, but of course, since we had an exception that couldn't be handled, we had to quit. Well, what does the user see in all of this? Well, I'm going to run exceptionhandling.exe from Windows itself without using Visual Studio, and this is what the user will see in case an exception occurs. They'll get details about the exception, and this is enough to scare off any user. In addition, they have the option to continue. Imagine the scenario, something unhandled, some exception has occurred, yet they have the option to continue. Clearly, this is not an acceptable place for end users to ever be. Click Quit, and the application shuts down. So unhandled exceptions get handled all right. They get handled in an unacceptable kind of way. If you want to avoid the ugly .NET Framework generated error messages, you can add a try block into which you attempt to run the code that might fail. Use a catch block to catch any exceptions that occur. If an exception occurs in the try block, code jumps to the most local catch block. We'll see an example of how that really plays out, but let's start by just creating a simple try-catch block. In this case, we'll try the simple catch example. It's going to run the same exact code, except this time there is a try-catch block in place. Here you'll see we have a try block in which we'll attempt to run the same exact code you saw earlier. I step in, and here I'll attempt to open the file. It will fail, of course. We'll jump to the catch block, the most local catch block, and here we'll display a message box indicating that something went wrong. And that's all it really takes to bulletproof your code. Well, of course, there are more details than that, but you've at least seen how easy it is to add a try-catch block to your code. As a matter of fact, Visual Studio takes care of much of it for you. If I have a void procedure, say named test, and in there I'd like to add a try-catch block, just type try, press tab twice, and Visual Studio inserts the structure of the try-catch block for you. You may not want to catch any specific exception, so you can just delete that. And you probably don't want to throw anything in here. We'll talk about throw later on. You might want to just do something. So you can modify it if you like, but it's easy to have them insert the structure of the try-catch block for you. Oh, and one thing. You can't have a try block without at least a catch block or a finally block. We'll talk more about finally later. If you try this, we have a problem. It says expected catch or finally. You can't just have a try block without at least a single catch or a finally block. But for now, we don't need this procedure, so I'll delete it. Next, we'll look at dealing with unhandled exceptions. What happens if an exception occurs, but there's no catch block to handle it? In that case, you pop back up the call stack looking for a catch block that can handle the exception. So imagine this scenario. You have a procedure which calls A, which calls B, which calls C, and in procedure C, you do the work that might cause an exception. In this case, it does cause an exception. Something goes wrong. Well, C has no exception handling. So the .NET Runtime walks back up the stack looking for a catch block that can handle the exception that just occurred. B has none. A has none. The original procedure does have one, and so we find ourselves back up in the original procedure running the catch block here. At this point, any further code runs back up in that top-level procedure. You'll never find yourself in A, B, or C again unless you call them again. The code that followed the call to B to C and the exception handling code in C will never run again. It's done. It's been popped off the stack. You're back in the original procedure executing code after that try-catch block at this point. You need to be aware of this because it's kind of scary the first time it happens and you find yourself in a procedure in which you didn't expect to find yourself. It may not be enough for you just to know that an exception occurred. You may want to know which exception occurred. To do that, you'll need to catch an exception. The exception class provides some useful properties and methods. For example, there's a toString method, which converts the name and stack dump as a string. The message property returns the error message that just got generated because of the exception that occurred. And the inner exception property, which can return another exception object. This will only be set if you in your code specify the inner exception property or if some other code has set this. This works because exceptions can be nested, and you can then walk the linked list of exceptions, determining every exception that got set along the path that handled this exception. A procedure can catch the exception, but throw it back out to the next level up the call stack, setting the inner exception property to be some specific exception, so that at the top level, you can see every procedure you went through to get there, or you could have multiple different things that got handled at different places. In any case, the inner exception, if it's set, can give you information about other handlers for the exception. Well, let's try a very simple example that shows how you can use the exception class. This time, I'll try choosing the simple exception option. Click the button, we walk into the code. This one has a try block, just like before. We fail in the same way, but this time we caught in our catch block an exception named EX. If I display the EX.toString, you'll see here the name of the exception, there it is, it's IO exception, the message of the exception, and exactly where it occurred in the code. That's what the toString method hands back to you for an exception. Well, that may be too much information. You might want to just put something easy out for the user to look at. So in that case, let's try this example. Same exact code, except this time we only display the message property. If an exception occurs, we display the message property. Note, by the way, that if you don't catch an exception, you can't retrieve any information about the exception. If you have catch without an exception listed, you'll never get any information about what went wrong. At this point, we see a message. Error occurred. The device is not ready. So at least you've told the user what went wrong. You didn't help them solve it, but at least they saw that the drive wasn't ready. Let's just prove that by choosing a different exception. And this time they see couldn't find a part of the path. And try one more. Come here, I'll press F5 to run full speed, and we say could not find the file. So you see the message property does give you useful information, it just doesn't tell you much about the exception. You might want to take different steps depending on which exception occurred, and for that we'll need to do a little more investigation. The .NET Framework provides a number of different specific exceptions built into the framework. And the documentation for almost every method lists which exceptions might occur when you call a particular method. For example, there's a file not found exception, which will occur if the file's not found. You can use specific exceptions to handle different errors differently. You can catch a specific kind of exception and handle it a certain way. You can add as many catch blocks as you need to handle all the different possible exceptions in different ways altogether. Now, when an exception occurs, if the runtime can pick a specific exception, like file not found, folder not found, and so on, it does. That is, if the method you're calling raises a specific exception, that's the kind of exception you'll get in your code. On the other hand, there is no exception for drive not ready. That's not built into the framework. So that one, when it occurs, raises a generic, or more generalized, IO exception. Now, IO exception can occur in a number of different ways. In the .NET runtime, we're going to trap it to mean the drive wasn't ready. Now, in your code, if the method you called raised an exception that you're not catching, you can catch it using the base exception class, if you have code that will match against that. And if none match, and there's no generic one, the runtime passes the exception up the call stack to the previous procedure that called this one. And it'll keep doing this, as you already saw, until it either finds a catch block that can catch this exception, or it gets all the way back out to the start, and it's handled by the .NET runtime. And you saw how that's handled, and that's not attractive. In our example, we're going to catch some specific exceptions, like there's an argument exception or a security exception. We'll have some specific exceptions that inherit from the IO exception, like file not found or directory not found. We'll catch the base exception, IO exception, so if the drive's not ready, we'll get that. And we'll also catch the real base exception class, exception, so if something occurs that we hadn't counted on, at least we'll still handle it. Now, I have to mention that the order of the catch blocks matter. The runtime checks the is a relationship for a match against the current exception. As soon as the runtime finds a match using the is a relationship, it runs the code and gets out. To test this, try putting the exception handler first in the code and see what happens. As a matter of fact, we'll do that. Let's investigate some code that handles multiple different exceptions to see how this can work. I'm going to choose multiple exceptions so we can see how you can handle multiple exceptions in one block of code. Here you'll see we're trying the same code, But down here we have multiple catch blocks for different kinds of exceptions. Argument null, argument exception, file not found, directory not found, security exception. Here we have an I/O exception, and down here, a generalized, just plain old exception. Well, right now, we asked for a:\autoexec.bat, and if I press F5 and run, actually I'll press F10 so we can step into our code. Here, you'll see we end up with an I/O exception because the drive isn't ready. There is no specific exception for drive not ready, so we end up getting this catch-all I/O exception. In our example, the only thing it should occur for is the drive isn't ready. Let's try a different one. Here we'll look for a file that doesn't exist, and we get file not found exception, as you might expect. Let's try one more. Let's try on a drive that doesn't exist at all. In this case, we get a directory not found exception because the folder doesn't exist. Now, the order of these items really matters. Directory not found and file not found both inherit from I/O exception. So if I take I/O exception and attempt to move it, I just cut it to the clipboard, I'm going to paste it above file not found exception. Let's rebuild this. And you'll see we get an error. A previous catch clause already catches all exception of this or of a super type. And we'll get that right here. Because file not found exception will never get matched. If a file not found exception ever occurs, this catch block will catch it. Because file not found exception is an I/O exception, and because these matches use the is-a construct to determine if it should catch the exception, we're done. I/O exception will catch it before file not found exception. This code will never run. This is an error that shouldn't occur, and it's nice the compiler won't even let the code compile in that situation. We need to make sure the order of these things is rational. So I'll place that exception down below, and now we'll build again just fine. Now, what would happen if we didn't have either of those generalized exceptions here? In that case, should an exception occur that wasn't one of these up here, it would say, hey, no one caught this exception. I'm just going to pass the exception back out to the caller of this procedure. Since the caller of this procedure also has no exception handling, it would bubble all the way back out to the .NET runtime, and you saw at the beginning of this section how well that works for you. It's not really acceptable. So you need to either handle your exceptions at each procedure or let them bubble out and have a generalized handler somewhere higher up the call stack. We'll see later how to create a generalized exception handler that handles the entire application. For now, just think how these different exception handlers work together to handle an exception within a procedure.